Okay, a pleasant afternoon, everyone. I hope you are very fine this afternoon, and I'm happy to see you again. Welcome to physics class. So this time um we will just continue about what we had just started last time. So last time we talked about heat. We also mentioned that heat is a flow of energy, and then we also describe about heat transfer and also thermal capacity. So we just ended up with specific heat capacity. So as I mentioned last time, when we say specific heat capacity, what does it mean again? Hmm? So when we say specific heat capacity, we say specific heat as the quantity of heat required to change the temperature of 1 gram of a substance by 1 degree Celsius. And that is how we define a specific heat. How much amount of heat is required to a substance or a material or object to change the temperature of 1 gram of a substance by 1 degree Celsius. And that is how we define or the concept of specific heat capacity. So I mentioned also last time that every substance, they have its own specific heat capacity. So I want you to remember some of those. I've shown to you here on the screen some of the substance that have rather specific heat capacity. For silver, we have 0.235 joule per gram times degree Celsius. For aluminum, you have 0.903 joule per gram times degree Celsius. And of course, for water, very common, we have a specific heat for water, which is 4.184 joule per gram times degree Celsius. So we can now, actually class, we can now describe specific heat capacity by looking at this equation, or it can be solved using this equation. Q is equal to M times C times change of T, where Q refers to your heat measured in joule, your M refers to your mass, which is measured rather in gram, and also C is the specific heat capacity which is given. So you really have to memorize or familiarize about the different specific heat capacity of all substances. So, because it is required in here in the equation or formula. And also the change of T means the final temperature minus the initial temperature. That means the change of T this can be attained by getting the difference of your final temperature and initial temperature. Do not forget how to find your change of T. You can find it by getting the difference of your final temperature and the initial temperature. So now, let's go. Let's proceed to the next slide. Okay, let's say the amount of energy you need to supply to boil the water will depend on two facts. Again, we can illustrate specific heat capacity by this example. The amount of energy you need to supply to boil the water will depend on two facts. What are these two facts? First, it it will depend on the mass of the water. The mass of the water will affect the amount of energy you need to supply to boil the water. So, the mass of the water. The second one is the increase in temperature. So, the increase in temperature, in order to calculate how much energy must be supplied or required to boil a certain mass of water, we need to know also one fact. Of course, under the increase in its temperature. So what is this fact? It takes 4,200 joules to raise the temperature of 1 kilogram of water by 1 degree Celsius. Again, do not forget this one. This is very important, especially for water. It takes how much? It takes 4,200 joules to raise the temperature of a 1 kilogram of water by 1 degree Celsius. So I want you to remember that one. Again, there are two facts that the amount of energy you need to supply to boil the water will depend on two facts. Again, the first one is the mass of the water. The second one is the increase in temperature. But here in the increase in its temperature, you need to remember that it takes 4,200 joules to raise a temperature of 1 kilogram of water by 1 degree Celsius. So do not forget it. Next is, let's assume that the cold water from your tap is at 20 degrees Celsius. Then you have to provide enough energy to heat it to 100 degrees Celsius. So its temperature must increase by how much? Yes, by 80 degrees Celsius. Again, based on the example there, let's assume that the cold water from your tap is 20 degrees Celsius. Then you have to provide enough energy to heat it up to raise a temperature of 100 degrees Celsius. So how much temperature must be increased to a 20 degrees Celsius? Of course, it's 880 degrees Celsius rather. So its temperature must increase by 80 degrees Celsius. So what's next? Let's also assume that you need 2 kilograms of water for all the drinks. How much? 2 kilograms. You need 2 kilograms of water for all the drinks. And then the amount of energy required for a 2 kilograms of water by 80 degrees Celsius is therefore energy required is equal, or it can be this, it can be solved in this equation, using this equation. Energy required is equal to 2, which stands for the 2 kilogram of water, times 4,200, which is a fact for a water to raise a temperature of 1 kilogram of water by 1 degree Celsius, the 4,200 joule, the specific heat capacity of water. And also the 80 is 80 degrees Celsius was taken from, okay, the temperature must increase by 80 degrees Celsius. How did we get 80 degrees Celsius? We just subtract 100 degrees Celsius to a 20 degrees Celsius to know how much the temperature increased by. So by multiplying this, it gives us 672,000 joules, or we can convert it or write it as 672 kilojoules. So that's how we compute based on the example that we have about measuring the heat capacity of water. So now, based on the solution that we have, we can now describe the formula or the equation on how to solve the specific heat capacity of any substance. Do you have any idea? Yes, you have the idea because I presented that one a while ago. The formula for solving the specific heat capacity of any substance. But in this example, we just use the water as our substance to measure its specific heat capacity. So now, to continue, specific heat capacity is the energy required per kilogram and per degree Celsius to raise the temperature of a substance. Again, we can define a specific heat capacity now as the energy required. That is the energy required considering the kilogram and the degree Celsius to raise a temperature of a substance. And that is how we can now define specific heat capacity. So I hope you'll not forget it. Okay? So the symbol used in the, okay, we can now rewrite the formula as this. Energy required or energy transferred is equal to mass times the specific heat capacity times the increase in temperature. How do we compute the increase of temperature? Later, I will tell you. Okay, so we can denote it as energy is equal to mc change of t, or you can represent energy as q, capital Q or small q, but we prefer small q. So q is equal to mc change of t. What is m stands for? M refers, or it stands for the mass. C is for the specific heat capacity. That's why you have to memorize the specific capacity of each substances or any substance. And then the change of T means or equals increase in temperature. Again, how do you solve for the increase in temperature? You will just subtract the final temperature, T sub F, subtract it to the initial temperature or T sub I. That's how you get the increase in temperature. Just get the difference between the final temperature and initial temperature. Do not forget it, because later on you will be using that one to find the increase in temperature or the change of T. Next, now take care here. The Greek letter, capital delta, so that is a Greek letter. We borrow this one. This one means capital delta is not a separate quantity in this equation. Instead, T stands for the temperature, and this one, the change of T, stands for the change of temperature or increase in temperature. Do not forget that one. Again, the capital delta or the delta T or the change of T means, delta T means increase in temperature. So how to get again the delta T or increase in temperature? How to solve it? Again, the increase in temperature or the delta T can be solved by subtracting your final temperature to the initial temperature, or increase in temperature is equal to the difference of the final temperature and the initial temperature. And that is how you get your delta T, or increase in temperature. Okay? So I hope you can follow, and please do not forget it. So now, in solving specific heat capacity or in quantifying your heat when a system absorbs thermal energy, then the formula that we use is this. It's here on the screen. It's very clear. You know, it's clear compared to a while ago. So heat now, or quantifying your heat, which is measured in joule and then represented by a letter Q. Again, Q means heat measured in joule or in J, is equal to M, which refers to your mass, which is measured in gram, and then C sub S, which is the specific heat capacity, which is measured in joule per gram times degree Celsius. So this is the unit for the specific heat capacity, and then multiplied it to the change in temperature, or shall I say the increase in temperature, the delta T. So this is now the formula in solving or in quantifying your heat. How much heat that a substance can absorb, or the capacity of its thermal, so, or heat. So now, I hope you can follow. Next, we will proceed to the next. Now, it's very important to, in order for us rather to appreciate the formula, we need to use it so that we will be able to remember and appreciate the use of the formula or equation. So this time, let's have an example. Let's try to apply about what you have just learned about the formula in solving the thermal capacity or specific heat capacity of any substance, or shall I say the energy transferred or required. So let's have an example. Example one, I will read. A domestic hot water tank contains 200 kilograms of water at 20 degrees Celsius. So here's the problem. How much energy must be supplied to heat this water to 70 degrees Celsius? And then there is a given of the specific heat capacity of water. Again, we have 4,200 joules per kilogram times degrees Celsius. And that is our heat, specific heat capacity of water. So this, it's the given. So the first thing that we are going to do to solve, again, we have to know what we know. Of course, we have to identify rather what we know and what we want to know. So in this given, you have a given specific heat capacity, which is 4,200 joules per kilograms degrees Celsius. This is your, this is the this your C, the capacity, the C in the formula a while ago. And then the next is, we have a given mass, which is 200 kilograms. As you can see, this is your M. And then we have 20 degrees Celsius that must be supply, how much energy must be supplied to heat it, to heat this rather to 70 degrees Celsius. So you have to, of course, in order to solve the energy supplied or required, we have to identify your first, your change of T, or the increase in temperature. Again, how to solve your change of T or the increase in temperature? So as I mentioned, to get the change in temperature, just get the difference of your final and initial temperature. Your final temperature is 70 degrees Celsius, and then the initial temperature is 20 degrees Celsius. So to get its difference, class, you'll just subtract it. To get the increase in temperature, then you have it 50 degrees Celsius. So our given now is complete. We have the M, we have the C, we also have the change of T, or the increase in temperature, which is 50 degrees Celsius. So I guess we are now ready to solve. I want you to remember the given, okay? So we will now proceed to the next slide for a while. I have to clear up all this. Okay. So now, to write down the other quantities, as I mentioned, I've wrote it. I have written it rather a while ago. So step number 2 is write down the other given. So as what I said, the other given that we have is rather the mass of water, which is 200 kilograms, the specific heat capacity of water, which is 4,200 joule per kilogram degrees Celsius. Now we will write down the formula for energy required. We will just, all we have to do is just to substitute it to the given formula. So the mass that we have, it's 200 kilograms, check. And then the specific heat capacity, it's given here, 4,200 joule per kilogram times degrees Celsius, yeah, check. And then again, that increase in temperature, we solved it a while ago, it's 50 degrees Celsius. So by just multiplying them all, we will just multiply the given that we have based on the, after substituting it to the equation or formula. Then it will give you a 42 million joules. Or you can rewrite it as 42 megajoules. So you can just rewrite it. I will still accept the 42 million joules if you'll answer that one. So 42 megajoules are required to heat the water to 70 degrees Celsius. And that is the meaning of the 42 mj. So it requires 42 megajoules to heat the water to 70 degrees Celsius. And that is our final answer. So I hope you can follow. Just remember the formula. Again, what's the formula? Energy required is equal to mass times the specific heat capacity times the increase in temperature. How to get your increase of temperature again? Subtract the final temperature to the initial temperature. And then you can get already the increase in temperature. I hope you can follow. So now let's have another example here. So another example, example number 2. Let's try to read example number 2. To determine if a shiny gold colored substance is actually gold, a chemistry student decides to measure its specific heat capacity. The mass of the sample is 4.70 grams. Upon absorbing 52.2 joules of heat, the temperature of the sample rises from 25 degrees Celsius to 57 degrees Celsius. Now, this is the problem. Find the specific heat capacity of the sample. Is it consistent with the gold, which is 0.128 joule per grams degree Celsius? So the first thing that we are going to do, of course, identify what we know, what is the given, and what we should know or what to know in the problem. So as you can see, the given that we have, so we can have it there. So the mass is given. So we have 4.70 grams. And then there is also a given 52.2 joules of heat, meaning to say the energy required or the heat required, 57 rather 0.2 joules of heat. And then also there is a given temperature, which is 25 degrees Celsius to 57 degrees Celsius. So what is being asked in here? You are going to verify, or you're going to what? You are going to find the specific heat capacity of the sample. So you are looking for your C. So this is what we are looking for. So we will use the formula. The formula is Q is equal to mass times C times, I'll write times change of time, or change of temperature or increase in temperature. So since we're looking for your C, what will we do here is we divide both side by M and then change of T. So divide M, change of T. So we can cancel M, M, and M, change of T. Then that gives us this equation. C is equal to Q over M times change of T. So to solve, after that, after deriving the equation based on the given equation or formula that we have, C is equal to Q over M times change in temperature, then we can now substitute the given. What is your Q? Your Q is 57.2 joules. So 57.2 joules. What is your mass? Your mass is 4.70 grams. You have 4.70 grams in there. And then next is we will get the change of T, or the increase in temperature, or the delta T. This one. So to get that one, we will subtract the final temperature, which is 57 degrees Celsius minus 25 degrees Celsius. So that gives us, so to solve that one, 52.2 joules over 4.70 grams, multiplied it by the difference of 57 degrees Celsius and 25 degrees Celsius, that gives you 0.38 joule per grams degrees Celsius. I want to remind everyone, when you solve, I want you to do not forget to write the correct unit, because your correct calculations will be useless if you have a wrong unit. And do not just give me a figure or a number. Also consider and include the unit. So that's how to solve it. All you have to do is just to memorize the formula in order to solve the some problems involving specific heat capacity. Now, this time, I will give you time to do your task. I want you to um, finish your task or your activity before the time will end, and kindly collect it. The school the representative or class representative will be the one who will collect it, and please upload it in my QQ Messenger. Okay, so I hope you are learning so far, and now you can start your task or doing your task. Okay, I'll just here, do not be hesitant to ask questions. Okay, I will be just here, I will entertain your questions or concern. That's it. So thank you for listening.